Hey everyone, welcome back to the channel and thanks for tuning in. I'm Jason Wehrli with WCFab, and today we got a quick little tour of our laser sheet metal shop. Our laser shop was a new addition when we moved into the building here in DeKalb in 2022. We've always had laser press brake type components in a lot of our products. It was always outsourced by local manufacturers, and we didn't have the capability to do it in-house in our old building. So when we moved into our new shop here in DeKalb 3 years ago, we made sure to set aside some real estate here in the warehouse to bring this process in-house to help speed up both lead times, improve production quality, and it also helps us tremendously with the R&D process on new product and one-off custom builds. So we'll give you a little tour here of the shop and show you how it all works. The first thing in the laser shop starts with the raw material. What we're looking at here is our raw sheet metal storage area. We essentially keep in stock many different thicknesses of aluminum, carbon steel, and stainless steel, everywhere from 16 gauge up to 1 inch. Our 4,000 kilowatt fiber laser can handle up to 1 inch steel, 5/8 stainless, and 3/8 aluminum. The sweet spot of a lot of the products that we're cutting on our laser range from 11 gauge to 1/4 inch in most material types. So we get this material in from our local steel supply house. We do source North American only materials here at WCFab. Obviously, you'll see if you've seen any of our videos, we're big proponents of made in the USA, and we go as far as trying to get as much of our product and raw materials sourced from North America as well. A lot of stainless steel comes out of Canada, but a good majority of all of our aluminum and our carbon steel is all here from the USA. As I mentioned, we've got multiple different thicknesses. We keep them on the shelf here because we can run different materials any day of the week here depending on what jobs we have coming through the shop for what type of parts we're making. We've got upwards of about 400, if not maybe 500 different parts that we cut on this laser on a regular basis. Throughout an annual basis across the year, there could be as many as 400 to 500 different part numbers run through this shop, all different components for our manufactured product. So here we are with our overhead crane. When we get a job, depending on what material it is, we'll pull it off the shelf with the forklift, and it will sit here we'll set the pallet on the rack, and we'll use our suction plate to lift that material up off the pallet and onto the pallet of the laser. So come on over here and we'll show you how the laser works. All right, so here we are over at the laser, and we've got Austin, our laser operator here, actually getting ready to do a pallet change to bring some finished cut parts out of the machine and take a new fresh sheet into the machine so it can start its next job. Go ahead and send it off, Austin. So there we have a quick pallet change on the laser. So a little bit of background on the laser we have here. This is a Trump True Laser 2030 model, which is 2 meters by 3 meters. So it essentially holds a 5 foot by 10 foot sheet of material. It's a 4,000 kilowatt fiber laser. So you've got the green screen there, just like a welding helmet, so you can watch the laser cutting happen without being detrimental to your vision, similar to a welding hood. So right now, as I mentioned earlier, we've got 1/4 inch carbon steel. So these particular parts that just came out was a run cycle for components for our traction bars. So the fresh sheet just went in the machine and it will run. It's got about an hour and 20-minute cycle time to turn that whole plate into finished pieces, which will then get removed and work through our finishing process. After getting cut on the laser, they will remove the parts by hand, and with certain tools, they'll knock out any pieces that might still be stuck in the part, and then they will get stacked on a pallet over here and get prepped for our finishing machine. So we'll move on over here and we'll show you our new finishing machine. So here we have our new Listmac finishing machine. So this is essentially a very glorified high-tech sanding device. This is actually a recent addition to the shop. Previous to having this machine, you would get a part off the laser, and you've got very, very small amounts of burr and slag along the edge. Nothing crazy, nothing anywhere to the extreme that a plasma cut or a torch cut would put off, but you do still have a very, very light burr. Overall, it's a very nice cut quality. But these types of burrs we can't have when it comes to powder coating, or even in a case where a component has to get welded to another piece. That slag and that metal along the cut edge there will be detrimental to the weld quality and the finish quality in the powder coat shop. So previous to our finishing machine, this was all getting done by hand with palm sanders, air sanders, orbital tools, and things like that. Very time-consuming process. So we've been doing our research for a little while here, and we landed on this nice finishing machine, which has essentially a sticky belt, 36 inches wide, and we can put the part on the belt, and you can set your speeds and your tension on all the sanding heads. We have a large belt that runs the whole width of the conveyor belt, and that will put a consistent finish across the part. And then the machine also has two rotating heads that have double spinning sanding pads. They will rotate while the heads are spinning, and that'll give us a nice consistent finish on the part. And then we'll come out the other side, we'll bring it back around, and we'll also run both sides of the part in most applications. And the nice part about the rotating heads is it's actually an edge brake. So the little bit of slag and material on the edge of the cut that I just showed you previously, that rotating head will actually break these edges and get rid of that sharp point for a very, very small radius, which is very important in the powder coat process. Just like automotive painting, if you have a sharp corner, your paint will always stray away from that edge, leaving a sharp corner that does not have protection of the coating. So you always want to have a radius on a corner, and this machine gives a radius on all these edges, even on the holes and any openings in the part, which would be very difficult to do by hand, especially difficult to do consistently. So that machine gives us a nice, consistent finish all the way around on any hole, on any edge, on any opening. It's also very beneficial in the fab shop when they get these parts and they have to fit multiple pieces together to be welded. They've got nice clean edges, there's no burrs holding anything up, and they have a nice clean surface to do their welding with. We even go as far as changing out the sanding heads and the sanding belt. If we're running steel versus aluminum, we'll use different belts so that there's no cross-contamination. You don't want to be sanding with steel and then run aluminum and then go and try and weld that aluminum part because it'll be cross-contaminated with carbon steel. So this is a really cool machine. It's really brought us up next level in our laser shop here, and it's helped tremendously down the line in the rest of the process of manufacturing, whether it be in the weld shop or the powder coat shop. It saved a ton of time at those benches and those workstations for having the final clean parts. We get a much more complete part out of the laser shop before it moves on. So another piece of equipment we'll show you over here that we use for some small components. With this finishing machine, you have a minimum size of part that you can run. If you get too small, it won't stay on the belt and the sanding heads will actually throw the part out. So in those cases, we'll run it through our vibratory bowl. All right, so our vibratory finishing machine. Small parts you can't run on the sander. A perfect example of that would be our small laser cut tags or any small size bracket, say under about 3 or 4 inches. So in those cases, we will use our vibratory machine here, where we can take a whole pile of cut parts and we dump it in this machine here, which has an abrasive media. In this case, small triangulated stones, and there's a light amount of water being dribbled into the media as the parts are running through. The parts will make their way around, run in here for a period of time. It might be 45 minutes or half an hour. And then we'll trip a lever and the machine will automatically unload where the parts feed out of the machine and either into the bin or onto the cart here. And that gives us a nice tumbled-like finish. It breaks all of your edges and gets rid of your burrs on the corners and rounds those radiuses, just like we talked about on the sanding finishing machine. Another thing I'll touch on that's a really cool process that's part of the laser operation. When you're cutting with the laser, specifically with aluminum, you have to have a shielding gas around the head. Similar to when you're welding, you've got argon or argon-oxygen mixture, depending on what type of welding you're doing. When cutting aluminum, we use different types of shielding gas. We can either use compressed shop air, we can use straight oxygen, or we will use nitrogen. And when cutting aluminum, for the best cut quality and the best speeds and the best edge finish, we cut with a high pressure nitrogen system. So there's 2 ways to have nitrogen supply on hand in order to cut that aluminum quickly and have the volume of nitrogen necessary to have that machine run for hours at a time using that shielding gas. So you can either get an outside bulk storage tank that gets filled up on a regular basis from your local weld supply house, or you can do what we did, which is an in-house nitrogen generation system. So what we have behind me here is a high pressure nitrogen generation system where we're bringing in our shop air at about 170 pounds. It runs through the nitrogen generator, which takes essentially the nitrogen out of the air, out of the compressed air. The air we're breathing right now is 75% nitrogen. It's removing that nitrogen from the air and it's creating 99.999% pure nitrogen into this bulk storage tank. Now that's not the only step. In order for the machine to use this shielding gas, it needs to be high pressure. So it takes our 175 psi shop air, filters out everything else, and gives you 99% pure nitrogen. And then it has a high pressure generator bumping it up to about 380 to 400 psi. So we're feeding roughly 400 psi high pressure nitrogen to the laser for that shielding gas, specifically when we're cutting aluminum. And we cut a lot of aluminum in this shop, probably close to 60% of what we're cutting on the laser is aluminum. So we go through a lot of nitrogen, which is why it made sense to have this generator in-house versus having the bulk storage outside. So that is the details of the finishing and the laser side of things. And the last step in our laser shop is our CNC press brake. Come on over here, we'll show you that. So another nice high quality piece of Trumpf equipment here. This does all of our CNC press brake work. We've got a full 10-foot bed width. And the nice feature about this, it is a 110-ton machine, which means that's its bending capacity. But the reason for the wide bed width is mainly so we can set up multiple operations, multiple bend operations. So you can pick up a flat part and you can go through multiple stations, especially these components that might have 5 or 10 different bends, and go through multiple steps so that you can have a finished part when you end, and you're not setting down and picking up a part multiple times to get a finished component. So like a lot of the other machines in the shop, it's CNC controlled, the laser and the brake. A lot of the programming gets done in the office. We'll build those bend files and the laser files and run them through the TrueTop software simulations, and then those get loaded out into the shop here via the Ethernet cables, and the operators are able to pull up those bend files, and as the parts come off the finishing machine, they get a pallet over here. They've got a bend process setup sheet. They'll grab all their different tools, do a setup, and they'll bend all the parts, and then that will give us the finished pieces that will go on the shelf for the fab shop. So a couple other examples we have on the floor here that are in process is we've got several components down here for the BHP product line, some components for the receiver hitches, as well as some different gussets for, those are actually for Duramax T4 pedestal. We've got some of our flat patterns of our modular workbenches here behind us. So this is a good example of being able to use the full capacity of that brake table, and we'll take our 92-inch benches. And again, this is the flat pattern. And these parts, because they're so large, will be a two-man operation. You'll have one guy on either side here, and you'll carry them over to the machine, and they'll put a brake, they'll put a bend line on each edge of that sheet, giving it our folded finished form so that it can go into the fab shop and get all the gussets added into it. So that is a wrap on our laser shop here at WCFab. It's a really cool process. We like showing everybody how we do this and how we do it in-house and the quality standards that we run by here. It's been a huge plus having this equipment on site versus outsourcing it. We've been running our laser shop for about 2.5 years now, and it's been a tremendous thing for us, both in the R&D side, being able to develop and make changes to product quicker during the development stages, and it's been huge to be able to help control lead times on actual production parts going through the shop. We can schedule and organize all these different pieces and make the best use of material and help keep costs down on parts versus dealing with outside sources and not having full control on where they're sourcing their material and giving us the best usage of that material and the least amount of scrap. So that's a wrap on our laser shop, and if you've got any questions about the process or anything else we do, or if you run a manufacturing business and you're looking to have some product laser cut, you can certainly reach out. We do also offer outside laser work. If you've got DXF files or CAD models of something you're looking to have laser cut or CNC bent, feel free to send those over to our sales team and we'll be happy to check the project out for you. Thanks a lot for watching.